Hello, everyone. Good afternoon. Can you guys hear me well? Thank you. So I see that participants are still joining. So maybe we give a couple of minutes for everyone to join. And hopefully the webinar link today was working fine for everyone. Okay, Vinod. So people are saying that link is not working. So, and I see that only 100 participants have joined. So maybe you can take care of that. Maybe people are struggling. Okay, guys, I understand that link was not working, and I have also told the SkillUpRight team as well. Okay, so I see that participants are joining. I think there is a problem with the link, so SkillUpRight team has taken note of that. Let's wait maybe 2 more minutes so that everyone can get in. Right, I'm going to share my screen now. Hopefully my screen is visible to you. And we are going to talk about the third day of the webinar, 22nd of July. Right, and today we will continue our discussion for CD. So we will understand how we can package an application into Docker, right? Docker image, and then how do we set up Kubernetes to deploy the same Docker image. Okay, so what I'm going to do is I'm going to set up two quick machines. All right, so here let me open up my AWS instance, and I'm going to set up two machines here, and I'll set up a Kubernetes cluster on them. All right, so we will see hands-on how can we create a Kubernetes cluster and how do we deploy our application on that. Okay, machines are booting up. Let's mark this as master, and this will be node. Okay, and Meanwhile, we have a discussion. What I'm going to do is, because it's a new machine, I will have to recompile our address book application, which I talked about yesterday. So I'm going to compile that application again. Now it takes 4 or 5 minutes, right? We don't want to wait that long and waste the time of the webinar. So I'm going to compile that application. So I'm going to also change the font size so that it makes sense to you guys. I am not sure how uh, this webinar jam works, but looks like there's a problem with the screen sharing. Okay, so I'm zoomed in. Hopefully it makes more sense, right? So I'm going to apt update. So we'll prepare our environment. I will need Maven, as we discussed yesterday, to compile and create a binary of our application. So Maven is being installed. It needs Java as well, so it's installing Java. There is a request that we make this as a white background. So if it helps you, I will also make it as a white background. Okay. So Maven is installing, and after this, I'm going to clone our address book application, which is, I'll just URL here, and just compile it. Right, that's what I'm going to do. So Maven is installed. I'm going to clone this. Sorry, I have to give the URL. I'm cloning my address book application here. Should be pretty quick. And Maven compile. I can just say Maven package. It's going to create a package for us. I'll let it run. Okay, this is gonna take some time. So let it run. Okay, and in the meanwhile, we'll talk about Docker. Okay, so what is Docker? Yeah, let's talk about what is Docker. So when we develop any application, right? When we develop any application, we have to well, before explanation, let's understand a scenario, right? For example, let's say you are an organization. Let's say you are the Applebite company, right? You are an organization and you are developing a product called Address Book. So Address Book is your product, and it's a shiny product. You want everyone to use it. It is built using Java, so it has the latest and greatest and things like that. So you want people to use it. Now it's a product. To use it, you have to install it on your environment. So maybe on your laptops or on your servers, somewhere you have to install this application. Now let's assume that this application requires Tomcat as a server to run this application and Java as your runtime environment, right? And it also requires some, let's say, OS libraries to interact with the operating systems. So this is our application and this is the deployment environment, right? Now you want your users to use it. That means you want your user to install this application. So what you're going to do, you're going to say, hey, this is my address book deployment file. This is my binary. Download it and then set up your environment. So the customer sets up environment. How the environment is set up? They will install an operating system somewhere. They will install the underlying requirement, that is Java. They will install Tomcat. and then they will take this binary and execute the binary, right? So this is how the customer will set it up, right? So there could be many things that can go wrong. Maybe, yeah, your address book application requires Java 1.8 to run, but the customer installs Java 1.7 or Java 1.11, for example. And because this is not aligned with the expected Java version, your application may stop working or may work, may have a behavior which is not expected. It may have unexpected behavior, right? So, how do you avoid the problem where you have different environments, different architectures of machines available, but you don't worry about them and you want just your application to work like that, right? So what you can do is you can package your application. So instead of delivering your application just like that as a binary, as a separate binary, you can create a big bundle of deliverable which includes your application plus all the dependencies. Yeah, so you can say, hey, I will not give you my address book binary. I will give you my address book binary plus Tomcat that is used to deploy it, plus Java 1.8 that is used to deploy it, and bundle everything together, and you can just take this binary. So instead of downloading the address book binary, you can take this bundle and execute it on your systems, on your customer premise, right? Now, it solves a lot of problems. First thing is your application comes along with your dependencies, so you don't have to worry about the dependencies here, right? Second is there will not be any dependency mismanagement or dependency mismatch. So you create this package here, and then this package will run on any environment, on any operating system, any environment, anywhere in the world. Wherever you can run this, execute this package, it will run. So you don't have to worry that if you have Java installed or not, or if you have Tomcat installed or not. No worries, everything is bundled here, right? That is achieved using containerization technology. So this is achieved using containerization, right? So what you do, you create a deployable bundle out of the application and dependency. Now, one of the solution to deploy containerization is Docker, right? Docker is the most famous solution right now for containerized applications. So you create a Docker image. You create a Docker image out of all these things. So this bundle which you will deliver to people is called an image, right? So you will create a Docker image and you give this image to your client. So maybe you have a client 1, client 2, client 3, right? This bundle will have your application plus dependencies plus all the binaries required plus any utilities required. Everything that is required for your application to work is bundled here together, right? And your client 1 can just download the bundle and run the application on their Windows infrastructure. Client 2 can download this bundle and run the application on Linux. Client 3 can download this application and run it on Mac. They don't have to worry about any underlying dependency mismatch, right? So this is the advantage that containerization give you. It packages everything required for an application and allows it to run on any platform, right? But there is one thing that is required is if it is a Docker image, then these clients should also install Docker runtime. They also should install Docker runtime on these machines. Yeah. So once you have the Docker runtime installed, you can execute images based on any um, or develop or packaged for any environment. Okay. So how do we do it? Well, first thing to do is let's install Docker on our machine. So here is my machine. Okay, sorry. Here is my machine. Okay, package is successful here. Now what I'm going to do is I'll say app install docker.io. This is going to install Docker for me. Well, actually, it is going to install Docker client and Docker runtime for me. I say yes. Now this is a command to run or to install Docker um, on Ubuntu. If you want to install Docker on some other platform, you can just go to Docker installation. On the Docker documentation page, you have installation guide for Docker. So you have Ubuntu installation. Then for CentOS or any Red Hat machines, you can use this documentation, right? So it is simple documentation. You can just follow these steps. Essentially, it just adds a Docker repository, which is already added on my AWS instances. So I just gave apt install Docker command. Okay, so Docker is now installed, and I can quickly verify it by saying Docker -v. Is Docker version 20.10.2 is installed, and this is the exact build. Okay, so Docker is available for me. Now, just to show you the power of Docker, there are many Docker images already pre-built, which you can use directly. So many vendors package already their application in Docker images and make them available, right? So you can go to, for example, Docker Hub. Docker Hub is a registry which stores container images. So right, so you can create container images or Docker images and publish them on Docker Hub so that others can use it, others can download and use it. So it's a place where you can share Docker images. Just like GitHub is a place to share your Git repositories, Docker Hub is a place where you can share your Docker repositories, right? And you can see here Oracle Web Server, Java, all these are packaged into our Docker images, right? And we can immediately use them. For example, let me find out one application. Maybe I can use Nginx, right? I can create I can run Nginx application based on Docker. So what I say Docker run, right? Docker run is the command to run an application from a Docker image, right? So I say Docker run and Nginx. Now I want this application to run in background, so I'll also say -d, right? And I want this application to be actually available for me um, from external machines. So I will also say -p, right? Now these options -d, -p, and many other options we can discuss in detail, but right now there is not much time. So we'll just stick with using them. So -d is going to run this application on in background, and -p is going to expose all the ports of this application so that they are available for us, right? And press enter. It says unable to find any image in my local machine, so it will pull the image from registry. So it's pulling the image, right? It's going to download the Docker image here. So it said downloaded newer image, right? And then it starts a container. Okay, so what is a container? Image is a static file which contains your application data. So your application plus all the dependencies and binaries, right? Whatever I talked about here. This is a Docker image. But when you execute the image, you create a container. So this could be, for example, like your ISO and the actual VM. So ISO files have the complete binary data for your VM. Just one second. Sorry about that. Okay, so yeah, so when you execute the image from, or when you execute an application inside an image, you basically download it to your system, and when you execute, it creates a executable, or it creates a new process which actually runs the application which is present in your image. This is called a container. So image is a static file which anybody can download, and when you execute it, it creates a container. So when I say Docker run created or downloaded my image and created a container for me. So if I say Docker PS is a command for Docker processes, and it shows me that there is a container running here. Now this is a multi-line output because we are zoomed in, but you can see that it is based on Nginx image. Each container gets its own ID, the default command that is executed inside the container, and then a default name that is given to any container, and also the application is available on this port on our machine. So I can now, my container is running based on Docker image. I can just go to this IP address and say 49153. Browse to this machine and this port. Press enter and I see Nginx. So Nginx is running now on my system. I did not have to install anything. I did not have to worry about any environment setup, any dependencies to be installed. Everything was inside my Nginx image. Docker run just executed the application based on the image, and now we have the application running. Right? I can stop this container. Stop this container here, and as soon as I stop it, you have your application is also gone. Right? There is no application available anymore. Okay, so this is how your containers work. All right, so now we are also going to create a container. So we just now packaged our address book application. So if I say Maven package, this command actually compiles the entire application, generates the binaries, and then package it together into a deployable artifact. Right? So this Maven package command creates our war file. The war file is required, or we can use this war file and deploy it in any Java container or Java server for running the application. So now what I'm going to do is I'm going to create a Docker container out of it. Right? I'll create a Docker image out of it. That's what I mean to say. I'll say, yeah. So to create a Docker image, I need to give Docker the instructions on how to create that image. So I'll say here I have already have a Docker file here. Now Docker file contains all the instructions about creating a new Docker image. So if I open the Docker file, it has just 2 lines, right? So from bitnami/tomcat, so use this Docker image and build a new image on top of it by pushing our addressbook.war at this location inside the base image, right? So what I'm going to do is, well, I'm going to copy this location of the war file here, and in my Docker file, I will say copy this war file. So use this base image and then copy this war file and put it inside at this location in the base image. So this base image already has Tomcat, and Tomcat is where I can deploy my application. So this war file can be deployed on any Tomcat server. So I'm going to take a Tomcat image and then just dump this war file inside that image. Right? I'm being pretty fast and pretty quick here because time. Now I can build a new image here. I can say Docker build. I'll give the image new name. I'll say SkillUpRight, right? Latest, right? And this command is going to build our Docker image. So our new Docker image will be called SkillUpRight. Done, right? It's done. If I say Docker images or image ls, I can see that there are 3 images now available. Nginx is the image which was downloaded when I demonstrated Docker run Nginx. Then for building purpose, Bitnami/Tomcat was downloaded, and we also created this SkillUpRight image, right? If I say Docker run -d-P and SkillUpRight, if I create a Docker container out of it, container will be created. If I say Docker ps or Docker container ls, it is going to show me the running container, which is the container based on SkillUpRight. And the application here is available on port 49155. So I'll go to my machine's IP address here, and I say go to 49155. And what do I see? Tomcat is available, and I'll browse to my application. And this is my address book application, right? So entire application compiled using Maven and then built and packaged into a Docker image, right? So anybody now can download this Docker image, the SkillUpRight Docker image. I can publish it on Docker Hub, and anybody can run this Docker image on their system and then get this application up and running, right? Just this Docker image. So now this image is enough for me to send it to my customers. Okay, so that's what Docker does for you, right? Now Docker does this, but it's not enough, right? For example, what will happen if I go back to my scratch board here, and if there is a machine on which you install Docker and you run a container from the Docker image, right? You're running a container, and let's say this container is Nginx based, and your external customers are accessing this Nginx application. What happens if this container goes down? The entire application will go down, right? So how do you ensure that this application is always up and running? So nobody should delete this container. If somebody is able to delete it, then it should come back up automatically. Or you can also scale up and scale down your containers, right? So maybe instead of running just one container for an application, you can say, I want to run a load balancer here, and users should access the load balancer, but inside load balancer, the load should be distributed among my various containers. So this all is enabled by a container orchestrator. For example, Docker Swarm or Kubernetes, right? And then Kubernetes also has some commercial versions like OpenShift, right? Or Rancher, things like that. There are multiple commercial versions, or also Amazon Elastic Kubernetes service, Google Kubernetes engine, things like that. So it's all based on Kubernetes here. So you can use Kubernetes to orchestrate your containers. So I will just quickly set up a Kubernetes cluster here. Should be pretty quick. I'll say snap install kubeadm kubectl kubelet. Let's see if it works. And I say kubectl. This will not work like this. So let's go the traditional way. Yeah, go the traditional way. Now I'm going to initiate a Kubernetes cluster. All right. So just give me a sec. Let's go to Kubernetes. So kubeadm is a utility provided by Kubernetes to create a cluster. All right. So I'm going to use that to install or to create a Kubernetes cluster. Okay. So these are the commands which I have to execute. So I'm going to execute these commands to get kubeadm and also other two utilities, kubectl and kubelet, in our environment. So you can all see the commands here, and you can follow the instructions here. I'm going to just copy the commands and run them. Yeah, so hopefully this will work. So you can see kubelet, kubeadm, and kubectl is running on installing on this system. Now on my other machine, so I need two machines on this cluster. So I created two machines right here. So I'm going to connect to this machine as well. And let's change the colors and also zoom in a bit. Right, so this is another machine which will act as a worker node of my Kubernetes cluster. Now, what is worker node? What is master node? All this I'll not spend much time there. I'll just show you how everything works. And I'm going to install Kubernetes here as well, right? So same commands up here. Yep, install everything. Okay, so kubectl, kubeadmin, and kubelet are being installed on both the machines which are going to be part of my cluster. Okay, so what I'll say is kubeadm init is the command which is going to initialize my cluster. Okay, it's going to create a Kubernetes cluster, and there are two more parameters that I need to provide to this. So which is pod network CIDR, which is some networking related input that I need to give here. And also because it is a low powered machine, I need Kubernetes to ignore the memory and number of CPU errors, because actually Kubernetes requires at least 2 GB of RAM and 2 CPUs. Well, I don't have 2 GB of RAM and 2 CPUs here. It's a free instance of AWS. So I'll say Kubernetes, please ignore these resource limitations. It says kubeadm not found. Kubeadm was installed. Ah, typo, right? Kubeadm. It says 10.250 is in use. Okay, snap uninstall. Give me a sec. Yep. So kubeadm init is going to initialize a Kubernetes cluster for us. All right. And we will connect the other node here as a worker node for our cluster. Okay. On the worker node, we also need Docker installed. Let's do that. So here the initialization is going on. What kubeadm is going to do is it's going to download all the components required for running your cluster and run those components, right? So all those components are also as Docker images, so it will run everything as Docker images there. And it may take some time to bring up everything. Let's give it some more time. Let's see if our machine is struggling with resources. Yeah, so let's go to monitoring. Our master node, yeah. Let's see about it. It is fine. Resources are there. Okay, let's go back to our machine. It looks like this may be stuck because of the resources. So what we can quickly do is we can stop this instance and increase the power here. So I'm going to stop this instance here, my master node. Unfortunately, this is an interruption, yeah, but once it is stopped, we can change the instance type. It's not stopping yet. Okay, let's change the instance type. I'll say T2 small. This may give it more powers, and let's start the instance again. Okay, now it is running. Let's connect to it again. Make it white, change the font size. Okay. Yes, I see that cluster is, I think, up. Many commands are running. So let me create the cluster again, right? Kubeadm reset. So I'm going to delete the Kubernetes cluster which was created before because I wanted to show you some commands. All right, so I say kubeadm init. Right, this is a command which I executed, and this time it should go pretty fast. And you can see the cluster has come up properly. right? Now to access the cluster, we need a configuration file which is stored in etc kubernetes admin.conf. So what we are going to do is we'll copy this file into our home directory .cube/config. Okay, so these three commands I need to run, and the command is run now, right? So as you can see, kubeadm was used to initiate or initialize our cluster. Now I can use kubectl to interact with my cluster, to talk to my Kubernetes cluster. So I'll say kubectl get nodes. It can show me which are the nodes that are installed or part of my cluster. So there is a node here, right? It says not ready, but we will make it ready. So there is a networking component also which we need to install. So I'm going to install that as well. I have the command ready. Now there are a lot of things that this networking is doing, but very difficult to explain in this short amount of time. So networking is installed, and also I will install the bash auto completion. So kubectl command auto completion I will also install. So I can just press tab and the commands will be auto completed. So I'll do that. So if I say kubectl get nodes, I see that my cluster node is ready. So there is one node which is a current node. You can see here with the host name here, the node name is also 44222, and it is ready. We can add one more node here. So from the kubeadm init command, we got an output, and this command can be executed on any worker machine or any machine to connect that machine to this particular cluster as a worker machine. So I'm going to go to my other node and run this command here, and giving it some time, it's going to create a cluster. So it says that this node has joined the Kubernetes cluster. kubectl get nodes, you see another node has come up here. It is not ready because some components are being installed there, and within few minutes it will become ready. So now you can see this node is also ready. All right, and now I'm going to deploy an example application, for example nginx application, right? I'll say kubectl create deployment based on nginx and expose the port 80 of that nginx application, and I will also give it a name, call it as nginx deployment, right? So I created this deployment here, and you can see that it runs one container for me, which is based on nginx image, right? If I say -o wide, it's going to run one container for me. Not much detail is visible here as of now, but yeah, one container is running, and this is a nginx based container, right? I can access the nginx application by creating a service or a load balancer on top of it. So I can say kubectl expose deployment nginx deployment type node port, and let's also give it a name. Name is not required, and I'll say port 80. So if I say kubectl get svc, so my application is available on port 31901. So on any of my node machines, if I go to their IP addresses, for example, I'll take this IP address and I'll browse to 31901. Do I get nginx? My nginx application is up, right? Let's try something else. I'm going to go to my cluster, and here I see that kubectl get nodes -o or get pods -o wide. This pod is running, and it is running on the node 183. Right, so I'll go to the node 183 here, and I say docker ps. I see that one container is running here with the image Nginx. And as I mentioned initially, right, what happens if the container goes down? The application also goes down if you're running with Docker run commands. But in Kubernetes, if I delete this container, I'll be mischievous and delete this container. Docker container rm and delete this container here by the container ID forcefully. And if I check the containers again, I will see that Nginx container is again restarted. So Kubernetes will keep an eye on all the resources like containers and everything. And if a container dies, it will restart it. So your application will always be available, right? Doesn't matter how many times I delete this container, it is going to come back up again. And your application will always be available, right? Now you can also create a scaled up, or you can scale up your application as well. So right now you can see there is only one container running here for your Nginx application. You can say kubectl scale. You want to scale my deployment, and the deployment name is Nginx deployment, and I want it to have 5 copies or 5 containers should run. Press enter, and you can see now 5 containers are started for the same application. Right, 5 containers are started, they are all running here. And even if one container dies, still rest of the pods or rest of the containers will continue to serve the applications, and this container also will be restarted automatically by Kubernetes. So your application becomes highly available, right? So your application will always be available at this URL. Doesn't matter if a container dies or if a node crashes, your application will always be available. So this is what we use Kubernetes for. Yeah, Kubernetes ensures that your application, which is based on Docker or based on container technology, is always up, always running, and is always serving the customers. Right? So this is a very quick, high-level, confusing demo, I guess, for everyone of you to just understand, what are the things involved to get this DevOps pipeline working. Now, if I go back to my pipeline here, right, I can see this entire end-to-end things happening. So compilation, any code change can do compilation, test, metrics, and package, and then you can build your Docker images on top of it, and then push it to Docker Hub, right? And from Docker Hub, you can just say, okay, run my deployment, and that will deploy your application automatically. Okay, so that's all I wanted to discuss with you in this webinar, the entire landscape of DevOps. Dhruv, you are right. Yes, pod can be deleted just like that. Um, will it be good to create replicas for this deployment? So I created replica. I increased the number of replicas. How do we permanently delete it in case it is needed? All right. So if you are done with your application, you can just say kubectl delete deployment Nginx deployment, and everything will be gone. Your entire application will be gone. If you say get pods, nothing, no pods, no containers. Right? So yeah. What is the difference between kubelet, kubectl, and kubeadm? Kubeadm command is to manage your cluster. So to start a cluster, to delete a cluster, and to manage some other aspects of the cluster. kubectl is to interact with the cluster, to deploy applications on the cluster, to deploy services, scale up, scale down. Any interaction that you want to have with your cluster is done using kubectl. And kubelet is a service which runs in the back end which is responsible for actually running the containers. At very high level, but a lot of things we can talk about on this. Does Skillin take care of using more than one slave automatically? Yes. Automatically, yes. Can we run multiple images in one container? No. Yes, Azad, it is too confusing. I know, but this is just to give you an idea. So in 3 hours webinar, it's very difficult to expect that you will learn everything and also not be confused. But yeah, I just wanted to show you the the expanse of tools and the technologies that we have in DevOps. Could we roll back to previous successful build if new build is failing? Yes, you can do that using in Kubernetes. What is the benefit of replicas? As I said, it makes the replication highly available. If one container dies out of 5, your application is still available. Right? What about dynamically updated database? Docker image can work with it. So we have Docker database images, but it is highly advisable that you do not run databases in containerized environments unless you really know what you are doing. When you have created the Docker image, you have mentioned name, then you mentioned latest after colon. So latest is the version. So when you say Docker build, right, I mentioned the name of the image and then this is the version. So latest is the version which I'm giving here. You can skip it and no version will be given. Is all the clusters running in the same physical machine you created? No, no, no. These are two different machines, right? This is one machine and this is another machine. Both have different IP addresses. Are pods and containers same? No, containers run inside pod. But for today's discussion, I just took the liberty to call pods as containers. How Nifi works in Docker? What is Nifi? I'm sorry, I don't have understanding of Nifi. How automation works after Jenkins to Kubernetes? Well, you have to integrate all these tools together, all these from Jenkins to these tools together to achieve the automation. What should we start first, AWS, Docker, or Kubernetes? So start with Docker, then learn Kubernetes, and then learn AWS. What are the requirements in an application to make it containerized? There is no specific requirement as such, but the thing is that it should be able to be self-contained application, should not be dependent on other application. SkillUpRight reps. Okay, this is a question for you, Vinod. Can I use Docker instead of Kubernetes for orchestration, the load balancer and all? No, not native Docker, but you can use Docker Swarm. Again, Docker Swarm is similar to Kubernetes, but it will be good to learn Kubernetes because that's what is a sought after tool, right? How do you edit a config file which is inside the container? So you can use config maps, something called config maps in Kubernetes, and you can upload that into a container. Okay. All right. So this is what I wanted to discuss with everyone. Yeah. Just a brief overview. You can say 3,000 or 30,000 miles, 30,000 feet overview and of your entire DevOps landscape. So you could have seen there are a lot of tools to talk about, a lot of things to learn, and just talking about them in 3 hours would have confused you a lot, right? So that is understandable. It needs a lot of time to understand these tools individually and then how they work together. Yeah. Okay. So that's all for today. Vinod, you want to wrap it up?
Yes, maybe we can.
All right.
We can end the session.
Okay. So thank you
Thank
everyone.
you. Bye.
You will be receiving the recordings, or you can go to the SkillUp website, and I think SkillUp team can help you out. Recordings there. Yeah. So thank you for your time, and hopefully I see you guys, or at least some of you again. And all the best for a career. All the best for your aspirations. And take care, guys. Be safe. Bye.